followers page. Gumaki nga.
Спасибо.
So,
Well, can we just try to recalculate the one rolling in?
Or buy you a few mothers and call it a day.
no, but
And we're not talking about the Well, that's
We can discuss with Cole. The name is too much. Okay, guys, so
Koi doesn't give a shit.
I think if it was 5%, it was exactly too much, but now it is at least 10%. So before it was 5%.
You should have done like what practical session you went for. You design like that one and another one maybe.
Yeah.
So
So
every
you compare all the data, but
yeah.
we work manually on one model.
Yeah.
Okay, so have you watched the video for the timber? Not yet.
No.
So the first part is only like introduction of the timber definition and timber. You want me to go through that? It's very simple. We can start from here. So some of the common wood in Australia or common trees. Hardwood, we have mountain ash, brown box, spotted gum, jara, turpentine, and softwood like radiata pine, cypress pine, hope pine, Douglas fir, and white cypress pine. So any one of you has attended the practical? You, right? The timber or not yet? So anyone has attended the timber? Yeah, sure. So the type of the timber in the practical is radiata pine. So radiata pine is MGB and F grade in the structural design. But we will lower our expectation, so we consider it as MGB 10 in the lab. Because also in the timber practical, we need to compare the data from the test to the theoretical data. But for the timber, it is very simple. We don't have like Excel calculation or graphs. So this is the type of the trees, and this is the type of the timber. As you know from last year, we have two types of timber: sawn timber or natural timber and manufactured timber. So sawn timber, this one already get from the tree directly, no processing. For the manufactured timber, it has some process steps. So some of the manufactured timber are like plywood, like this one here, or close lamination. We have laminated veneer lumber. This also we call it LVL, vertical lamination. So it depends on the direction of the lamination. If it is vertical lamination, we call it LVL. If it is cross, it is plywood. The third one is glulam or glue laminated timber, which is horizontal lamination. Okay, so this one is the vertical lamination or LVL. This one is the horizontal lamination or glulam. Which one was the highest strength, if you remember from your last year course?
I think it was glue lamp.
Yeah. So glulam was the strongest one. Okay. So this is just some definition about the type of timber.
What's
So
this?
the strength of timber. So we have each timber product is graded to determine its strength probability. So we have visually graded timber. The visually graded, like the F grades. So F grades is visually graded timber, and this is under standard 2858 and 2082. And also we have the machine graded timber, which is MGB grades. If you remember what is the MGB grades 10, 12, and 15?
Yeah.
Remember? So we have AS 1748 and AS 3519 for the MGB. And we have manufactured product, which is LVL, glulam, and plywood. and the standard for each one is there: 43, 57, 13, 28, and 22, 69. Based on the use of the member you are designing, you choose the timber. If you remember last year, we choose the lowest grade of MGB for the buildings or bracing, sorry, if you remember, and for the rafter and column we use what MGB, glue lam or LVL. So LVL and the glue lam are high strength or strong timber. But MGB are lower grades or lower strength. So based on your design or what is the member you are designing, you can select the type of the timber. So this example of the visual grading timber. So this stamp has a lot of like most of the varieties we need for the timber. So this F grade. So what is the grade, stress grade of this timber? F5. And the grade method, visual stress grading. The grading standard is AS2858. What else?
Seasons.
Yeah. The type, we have two types of timber, if you remember, unseasoned and seasoned. Which one is better?
Season.
Seasons, because they remove the moisture
Moisture
from
content.
the
Stiffens and
stronger and stiffer.
uh,
So this beam bind is the manufacturer or the mill. The species or the tree is the data bind. So this stamp has all or most of the data we need. Actually, what we need in our structure design for timber, two information: the grade F5, what else? Seasoned or unseasoned. So these two information are important. For the machine graded MGB, how they grade the machine graded or the MGB? So MGB is abbreviation of machine graded bind. So we have minor access building test, estimate of E or MOE, modulus of the system, and minimum in these given stress grade. Okay. So this example of the machine graded one. For the manufactured product, we have LVL, laminated veneer lumber, and glue lam or glue laminated timber, and the glue generally tested by the manufacturer. So we can use the manufacturer test data to use in our design. Can you see this table? Is it clear? So we have two brands here or two types here. Highest band. Do you remember using highest band last year, or remember the table we print for you? So this gives you the bending or the strength for bending, and give you the shear strength Fs, and tension strength, and compression strength, and compression parallel to the grains, and the modulus of elasticity and the modulus of rigidity. So the properties for timber, for the glue, for the manufacturer will be extracted from where or where we get it from the manufacturer data. Okay. So for example, what is the compression strength for these two types? 41.
Yeah. I met him in down at Wembley the first time he came to League. Met him there for a couple times, and then I saw him at Ingleberg. Yeah.
Yeah, he was hosting.
Seasoning of timber. What does the seasoning of timber mean? Seasoning is drying of the timber. So the timber, as you know, can absorb the moisture. So if the timber absorbing moisture, this will make it quicker. So seasoning will make it more stronger because we are removing the moisture from the timber. the
He was hosting their table, Bateman's table.
this reduces the moisture content in the timber to make it dimensionally more stable and strong.
That's how you got the job.
Also, when we remove the or when we season the timber, it will like lose some of its dimension.
What the hell?
Seasoning can occur by air drying, oven drying, or by microwaving
Yeah,
in
it told
an
me.
industrial oven. So how can we do the
Global
seasoning
India.
later?
PMI?
Air drying, leaving it in air or in oven or in microwave. Okay.
Advanced system? What it should be, it's alright.
It's not quiet.
So what is the effect of moisture?
He was like, oh.
As I mentioned, the dimension of the timber will be changed or reduced due to the
Who's that guy that assists at Westport?
removal of the moisture.
That's what he
So
said.
timber shrinks as it dries.
It's at least a guy that was saying, he was like, he's very expert. He was talking to me. Yeah, I was trying to ask Tom Bateman about this question.
So this can result in twisting and dragging along the length of the timber and also in the reduction of its cross section. So if you read this red sentence or red book here, so we assume that the timber will lose about 3 millimeter in both sides, like the width and depth, due to seasoning. Okay? So again, as the timber dries, it loses moisture, so that will shrink. When it shrinks, we assume it loses about 3 millimeter in width and depth, or in width and depth.
One of the photos that he didn't want to go I just wanted to come to Australia also. Yeah.
Okay. So another effect is the temperature effect. High ambient temperature reduces the strength of the timber. So the high temperature reduces the strength of the timber. Timber structure and locations such as Darwin and other tropical cities will be affected by this reduction. So because Darwin, as on the north of Australia, is a little bit hotter, warmer than here, so this will affect the strength more than here. So this means it depends on the location when you construct the timber will be some factor will affect that. Okay. So strength is modified by a factor K6 because K6 is a factor to account or consider what
It's initially thinking
temperature
it's
effect.
but it's too much. Yeah, because I was initially
So-
going to do Monday, but Corey does Tuesday.
This is the first factor, effect of moisture, effect of temperature. The second one is the effect of the duration of the applied load. As you know, timber is susceptible to the creep and shrinkage. So this means when you leave the load too long time on the timber, it will make effect on the timber. So what is the factor of taking this into consideration? K1. So K1 is a factor or modification to account for what? Duration of the load application.
Yeah.
So the timber strength reduce along the time. If the load is permanent, dead load or storage life load, this strength reduction will be considered. How to consider this? K1. This is some example of the timber construction for residential building and for this roof. So this gives you definition or names of the members of the roof. What is this member mentioned here? The member in the middle at the top of the roof is the ridge beam. So the ridge beam is supporting what? What is this red one? This is the rafter. So we have the ridge beam and the rafter supporting on the ridge beam. And what is buttons? So what does the buttons mean? The buttons like burnets in steel. So the buttons here are parallel to the ridge beam and perpendicular to what? To the rafter. And the roof will be on top of that. Okay. What other members here? Hanging beam. What does hanging beam mean? Do you know what does hanging beam mean? This wide beam. So
for
this is-
hanging the battens and plasterboard and other stuff like that. So like the
Yeah, you see this horizontal elements here. So this beam is hanging this horizontal beam or horizontal joist. Sorry. Okay, so this is the ceiling joist. The white ones are the ceiling joists. So the ceiling joists are hanged by the hanging beams. So the hanging beams are horizontal because if the roof is like that, pitched roof, so you need horizontal elements to carry the ceiling. Like this ceiling, we need some support for the ceiling. So what is carrying the ceiling? The ceiling joist and hanging beams. What is carrying the roof? What is carrying the roof of the The rafters. What else? The ridge beam and the button. So the button similar to the Berlin in steel. So button supported by the rafter and the rafter supported by ridge beam. This is an example of roof members. This example for wall members. Do you know the wall members? What is the wall members is? So for this part, we have studied this in masonry. What is above the window? Lintels. We have lintels. What else here? This is members that carry the wall or carry the gypsum board or whatever the wall, the wooden wall. So wall studs. And we have bottom plate and top plate. Then you can just maybe nail the sheet to make the wall. So all the wall support will go where? To the wall studs. You know, they put the sheet here and then nail it to the studs. And this is the flooring. The stud near to the window, we call it stud jamb. Okay. So this is example of the timber building. This is the floor. So for the floor, also need some elements to carry the floor. What will carry the floor? The joist. So the floor joist. We have floor joists, and here maybe at the end we can have double. Why we can have double joist here? Because this joist will carry the right side, and this joist will carry the left side. If we have something from this side, we have also the bearers. So the bearers are actually the beam that carry the joist. So the joist transfer its load to the bearer, then the bearer transfer its load to what? To the column or the stumps. Okay? Do you have any question about this part? Now what is the second part? What is the timber design? Which standard we are using for timber?
SA
S
11720.
1720, part 1. Do you have a copy of this one?
Yeah, we
I
should.
didn't bring it, but I got one, yeah.
Yeah, you got one from last year?
Yeah.
No new version? No? Okay, so what is the general aspect of timber design? Similar to any design code, we have 5. What is 5? Reduction factor for the capacity. So the reduction factor is actually like factor of safety, so that you don't consider the whole capacity, you consider part of or reduced capacity. So the capacity factor gives the consistent reliability to whole structure, allow for the chance that structure may not achieve the predicted strength. Where to find the 5? Table 2.5 for members and 2.6 for what? For connection. So we mainly in this course we are designing what? Members, not connection. So where is to find the table
2.5.
Yeah, 2.5. So table 2.5 of AS 1720.1 to get our reduction factor fall. Okay, we may have an infinite from the table to see. So similar to masonry and steel and concrete, based on what is the strain, what is the load applied, like shear, bending moment, and so on, we will find the phi. Okay, so if we quickly go to the switch type.
Where are you at the moment?
So we just do one shift office and stuff. It doesn't do before me.
We're going back to that.
No.
Teams, we're going back there.
No.
I think we need to get it done on the finish done and then they become extra.
This is the one where I was
Street
saying,
Yeah, Charlie, yeah. We got the valves delivered today. We got the crane,
Yeah.
they just we have to put it below. So we will get it done by hopefully this week. What's that Asian guy's name? Yeah, that Asian guy, that guy works such a, that guy is such a good worker.
Oh, Josh Rowley.
Yeah, that guy.
Yeah.
But yeah, like,
These is that
white
choice.
accent, like a big white accent. Like
Yeah.
a proper white
No,
accent.
he's half Japanese, half Australian.
Nah,
He worked so much because he tore his ACL playing footy like last year, so he used up all his legs. So I was like, he can't say no in the house. Get to work, but yeah.
I think he worked. I also enjoy like two, 3 times last year.
Okay, so just a typo here in the slide again. So actually table 2.1, not table 2.4.
Yeah.
So for members, where is table? Which table? 2.1. Okay. So for example, for glue laminated timber, how much is phi? Phi can be 0.95
Yeah.
or 0.85 or 0.75 based on the type of member you are designing.
Yeah.
If you are designing structure member for houses or secondary member in structure other than houses, it is 0.95. If it is primary member in members other than houses, it is 0.85. Okay? If you remember last year course, what was the project? Warehouse. If you remember, it was not warehouse, it was the library. Remember the library. So the library was building other than houses. So in this other than houses, you can use what? 0.85. It is a primary member. What is primary member? After column. What is secondary member? Berlin, racing. Okay. So now we go to the slides again. So the capacity factor, if you look at the table, it will depend on what Michael, the type of timber or the grading, like stone or glue laminated and so on. The strength probability, if it is under building or tension or compression. Type of structure, if it is house or other like warehouse or public building or something like this. Type of element, primary or secondary. Okay? This is all clear from the table already. grading and production or production method. So grading or production method dictates the reliability of the strength data the trainer used in calculating the capacity. So each type of timber has different reliability. This means when you test the timber, like when you will see the timber black, some samples are very good, some samples are weak. So this means the reliability of some timber is not high. That's why the factor 5 will be this for them. Okay. So products produced with higher degree of quality control, like Glulam and LVL, has higher response. If the designer unsure of grading method, conservative use factor for visual grading. Okay guys, so this is all just explanation of 5, not very important. Okay, so here the slide shows the table, but then now here 2.1, so it was a typo in the first one. So it is this table we saw previously in the standard. So it is some timber for some timber, if you can see. It is lower 5. Why it is lower 5? 0.9, 0.7, 0.6? Because the some timber, the probability of it is variable, not very consistent. That's why to be in the safe side they use lower 5. Okay? But for LVL and Glulam, it has higher values because it is manufactured, so it has high quality, better quality.
There's no area that we're going to use those properties, just scale it however we need. So based on that, I said to him that what we showed that before, like we don't have an ordinance in that ratio, nothing. Just take it as it's been tried and tested by the moment and it's worked for it. So we will change. There's a lot of things I try to work backwards, but it doesn't work out right, especially because it's
So for the strength probability, some probabilities change with grade, like F bending, F prime bending, F prime compression, F prime tension, and F prime shear. So the capacity factor varies with grading or production method.
Craig, or I'll try and email Craig and say we've got this.
Oh, John,
Some
how long
This-
does the
that
practical
don't
go?
really use it.
Half an hour? Huh? Yes, sir.
I thought you were asking him to stop talking. You
yes,
joined the talk. So I will stop to join the talk with you.
Sorry.
Because if I fix it talking, so
No, did not stop.
you will stop.
Probably most likely.
So some probabilities, like for example, the bending known with greater reliability for machine stress, higher capacity factor. So all of this is just explanation of 5. So it's too much for that.
Yeah.
Right? So you go to the table and find 5. That's it. Okay.
We even have it available when it's before.
So this table gives us some example of the if grade timber. What is if grade timber again? It is visually graded. So visually graded means it is by visual method, not by machine method like MGB or manufactured.
We need to test anyway.
So in table H21
Because Craig was.
give us the characteristic probabilities of F34 up to F4. So this is the grade. As you can see, the first one of F34 is the highest grade. So it has higher bending capacity, higher tension capacity, and higher shear. And also, can you see the difference in the Young's modulus? 21,000, here 6,000. So F34 is the best grade for F grade, F4 is the least one. So these properties we need in our design. So if you want to calculate the capacity of a column of timber or something, you need to refer to the table to get the data. Okay. This is just the strength. For example, in the masonry we have FMB. So this table gives you the probabilities of the material. Okay. another example of the timber, MGB.
No, that one's true.
MGB means machine created by.
I thought so, yeah.
We have MGB 10, MGB 12, and MGB 15. Okay, so for MGB 10 is the lowest one. Okay. Can you notice that MGB 10 is the lowest? So for bending, MGB 15 can reach up to 39 in bending capacity,
Yeah.
and MGB 12 up to 28, MGB 10 up to 17. Okay, this actually is the timber we are using in the lab tomorrow. So you will notice the size of the section we are using tomorrow is 190 by 35 or 190 by 45. So can you see the standard size of it? What is the standard size for MGB? It can be only 35 or 45. So the depth can be 190 or 290 or 90. Okay? So tomorrow, some groups will be testing 90 times 55. Some groups will be testing 190 times 45. So all the timber I was buying, or we can consider it as
Because I want a badge.
MGB 10. So this one information before going to the lab tomorrow. This is the properties of the glue lamp or GL grade. So GL grade is the highest grade compared to the MGB and F because it is manufactured. So what is the bending capacity, for example, here? We have grade from GL18 to GL8. So as you can see, the bending capacity can reach up to 45.
Yeah, it's not bad.
Okay? So this table gives us some examples of the properties of the timber.
What's that? When you run the first time, did you get
After we know some example of the properties, what is the next step? We know the factors affecting the calculation. So for example, if we look to this formula, what is this formula is? This formula is the capacity of the timber member under tension. So what does NDT means, Michael? Member capacity under tension. So ND design, T for tension. So what is the formula? Phi NDT equal to phi times K1, K4, K6, F prime T, AT. If you memorize the timber design before, it has many factors. It is easy but has many factors. So this is an example of the formulas, one of the formulas we have. So what is the first factor we have? K1. What is K1 account for, guys? K1 account for the duration of the load. So duration of the load means if the load will be applied for long time or short time. Why this is important? Because of the creep and change. Because when you apply the load for long time on timber, it will cause creep or
So we have to find it critical.
yeah. So just quickly, what is K1 here? As you can see, K1 is the time or the duration load factor. Where to find the duration load factor, guys?
G1,
Table. Which table?
G1.
Yeah, 2.3 and G1. So we have two tables for that, for K1. So long duration loads reduce strength of timber, damage fibers, not recoverable, and accumulates over time. Each load combination taken separately to find K1. So because as you know, what is the type of load we have in our calculation, guys? Do you know what is the example of the load we have? Dead load. What else? Dead load G, live load Q, and wind load double. Okay? And in table or in standard 1170.0, we have somewhat load combination. So we have load combination 1.35G, load combination 2, 1.2G plus 1.5Q. 3, we have 1.2G plus 1.5 psi CQ. Number 4, we have, do you remember, 1.2G plus W plus psi CQ, and so on. So I have loads and load combination. These loads, are they applied to the structure with the same duration or for the same duration or different? The dead load will be on the structure for the whole time, right? So it's longer duration.
Yeah.
Live load, it can be for shorter duration. Wind load also for shorter duration. So when we are applying K1, we need to consider each load alone and each load combination alone. So each load combination taken separately to find K1, the duration of shortest component of each combination over live structure determines K1. So if we look to this table, if the load is applied for 5 seconds, how much is the factor? K1, 1. So K1 is 1 for 5. What is the load will be, which load will be applied for 5 seconds, for example? Wind load. The wind load are applied for short duration. So the wind load actually will be between 5 seconds to 5 minutes. So what is the factor? 1. So K1 for wind load can be taken as 1 for the members. 5 hours to 5 days, 5 hours and 5 days and 5 months. So live load also is not for long time, right? So depending on what is the type of live load, it can be applied for 5 times or 5 days or 5 hours. What is the last one here? 50 plus years. Which load will be applied for 50 plus years?
0.7.
Dead load. So dead load, what is the K factor for dead load calculation? 0.56. So the dead load is applied to the building for the whole entire life. So that's why it will cause problem. That's why how much is K1 for life load for dead load, sorry? 0.56. Okay. This for the loads. For the load combination, if you look at the table G1, when you apply the load K1 for the load combination, for the first one, what is the load in the first load combination? G. So G is applied for long time. So how much is K1? 0.56.
Yeah.
So for live load, roof live load, floor live load, we have 1.2G plus 1.52. So the standard gives us a list of the values of K1. So if you are designing a roof, how much is the factor K? 0.494. If you are designing a floor, 0.8. Okay. If we have wind, so wind, as we mentioned here, wind is very short duration load, right? So if you have wind in your load combination, so how much is the factor? 1. If we have permanent and long-term life load, if the life load is long-term, so this means it is considered as what?
50
Dead load.
Yeah.
Okay. So for example, this furniture here in this room, it will stay here for 2-3 years. So we can consider it as what? As permanent. So how much is the factor? 0.52. Okay. So K1 is a factor that depends on the load duration. So K1 minimum 0.57 for dead load and permanent life load, and for wind it can be taken as what? 1. So for wind 1, for G or dead load as 0.57. We will see example now to know where to use this one. This is the first factor K1. Another factor is our factor K4. What is K4 account for? Partial or seasonal. So K4 is account of the factors that consider seasoning. So strength of timber is a function of the moisture content. So seasoned timber means the initial moisture content is less than 15%. So in the tables of the standard, he gives you more than 15%, less than 15%. What is more than 15% means? Instance unseasoned. So moisture content more than 15% means unseasoned. Less than 15% means what? Seasoned. Okay? So put it here. So we have K4. So K4 is a factor that accounts for seasoning. So we have moisture content less than 15%, moisture content more than 15%. Less than 15% means this timber is what? Seasoned timber. More than 15% means
How's Michael doing?
unseasoned
Michael, project
timber.
manager, project engineer.
Okay?
Yeah, he's good. Too busy.
So covered situation, indoor dry environment, we can take K4 as 1.
Busy.
Wet environment
Yeah,
or
he has too much
moisture
to do.
content more than
There's
15,
always something.
so K4
Too much
should
to do.
be more less than 1. So K4 is actually a reduction factor to account for the moisture or the seasoning.
See you, Craig.
So it is unseasoned more than 25. Okay, so less than 15 seasons, more than 25 is unseasoned. So for unseasoned timber, all situation we can take K4 as 1 for conservative, and we can use K4 more than 1 in the right environment and longer duration with it. Okay, so we can have a look on this one. So if we look to this part here, for unseasoned timber, generally K4 can be taken as what? 1. Where unseasoned timber is used under normal condition of temperature, will not subject to its full design load until it is partially sealed. So how much is the factor for this, how much is the factor K4? So if the thickness or the width of the member is 78 millimeter, we can take it as 1.15. If it is 100 millimeter or above, we can take it as 1. Okay, for seasoned member or seasoned timber, the value of K4 shall be determined as the meter of 1 minus 0.3 AMC minus 50 divided by 10 or 0.7, where AMC is the highest value of the annual average content that timber will attain in cell. So we will be able to use this later. But what you notice, K4 is less than 1 for seasoned and more than 1 or 1 for what? For what? For unseasoned. Okay? Sorry. So, because I watch the recording, when I come close to the camera, not good. So K4 is 1 or 1.15 up to 1.15 for unseasoned and 0.7 or we will calculate it for seasoned. Today we just introduced the topic, not going into detail. So this is the table I show you. So if the thickness less than 38, how much K4? 1.18, 1.15. If it is more than 100, it is 1. So thinner timber becomes partially seasoned quicker. This is the comment. So why they give K4 more to the smaller width sections? Because what does seasoning mean in fact? Less moisture. So when it is smaller, it will lose the moisture quicker than if it is wide. Okay? It's like when you cook something much when it is thinner, so it have you cooked before? Matthew?
Yeah.
I think you think about dinner now because it is
Yeah, that's exactly what I'm thinking.
dinner time. Okay, so this is a summary of the K4 factor. So simple and conservative values for the K4 factor. For seasoned timber, we can take K4 as 1 if it is in protected environment, or for example, the timber is wrapped or covered by something or painted. If it is in moisture environment, we can take it as what? 0.7. For unseasoned timber, we can take K4 as 1. Okay? So the minimum of K4 for unseasoned is 1, the maximum for seasoned is 1. So 1 can be used for all of the seasoned and unseasoned timbers in special conditions. What is the next parameter? What is the next parameter? Ben? What is the next parameter?
Temperature.
What is the last parameter?
Temperature.
Elastic last. They are not with me. What is K6? Don't follow Daniel. Don't follow Daniel. Daniel, it's first time to attend a class this semester.
Oh,
right?
whoa. It's like 4.
Fourth?
Relax.
You
Yeah,
can-
I mean, some quiz ones.
You consider when you come and the last minute is
I fell asleep.
okay.
Hang on, some of us start work at 5 in the morning, so
Oh, wow.
it's sleepy.
Yeah.
Mom doesn't care.
Not an excuse.
Sorry, no excuse. I'll do better.
Okay.
Sorry.
So what is the last factor in this formula? K6. So K6 is the temperature parameter or factor. So
It's usually one.
yeah, high temperatures over extended time decrease the strength of the timber. So high ambient temperature will reduce also the strength. That's why we need to consider it in our calculation. So K6 can be taken as 1 in most areas, and will be taken as what? 0.9 in where in this you see this hatchet area. So this hatchet area is like warmer area or higher temperature area. That's why we take it as 0.9. So K6 can be 1 or 0.9 based on the location. So K6.9 for seasoned timber in hot tropical climate, like these areas, like Cairns, Rockhampton, and Darwin. Have you been to any of these places? Okay, so K6 in the hot and the sterile areas can be taken as 0.9 or usually less than 1. Okay guys, do you have any question on this slide? Okay, now our last thing is this example. So problem 1 for the workshop. This is what we should do. I think you are more familiar with timber compared to masonry, right?
Yeah.
This is what it should be.
Yeah.
Okay, so what is the first example mentioned here? We just have examples to check the factors and the things.
Oh my god. I cannot wait.
So check the timber wall stud consisting of seasoned MGB timber member, MGB 15, and the size of this member is 290 times 45. In residential house, knowing that the wall stud is 5 meters tall and 3 wall studs share the roots in the system. So as you can see, the loop, the vertical loop, is shared by the wall studs. So if you have, that's why they have many wall studs, so that they can share the loop together. The spacing between the shear studs is 400 millimeters. The house is located in the northernmost part of Darwin, which has very high humidity. The unfactored axial load from the roof acting on the wall stud are 20 kN. Long-term life load is 10 kN. He asked us to determine the factor phi, K1, K4, K6 in this scenario or in this scenario, and then determine the critical load combination acting on the wall stud for the ultimate state design. So let's start with the first question. How much is phi for this one? We know. Where phi come from? Table 2.1 for member. If we go to table 2.1, what we can see? So what we need to do to use this table, we need to know the timber type or the timber grade. What is the timber grade in the example?
MGP 15.
Which one is MGB?
The first one.
First one. Sawn timber, under sawn timber. Okay? So 5, first information, MGB 15. What else? We need to know if it is primary member or
It's primary.
primary member or secondary member, and if it is house or not house. So
It
this
is a
house.
house, yeah.
It is a residential house. And is it, if you look to the table here, the table here, structure member for houses for which very well unlikely to affect an area greater than 25 meter. Okay, so which phi we will use?
0.85.
Yeah, 0.85. Why? Do we know the primary section or section? We take it 0.95. Is it 0.95 or 0.85? What do you think? 95.
Why? Second.
Structures other than houses.
Primary members in structure other than houses.
Because we are checking what wall stud, right? This wall stud is
It's
structure
secondary
member.
member, yeah.
So structure member. So how much is 5.95? Okay.
Yep.
Do you agree, guys?
Yep.
Jimmy, Matthew, run
But isn't that for houses?
Really? What?
That's
Isn't
what he
that
said.
structural members for houses?
Yes.
And isn't this an office? Or is that part 2?
Part two? What do you mean by that?
In the questions.
Yeah, we have question 1 and question 2. We have question 1. Tell. Question 1. Question 2 is office.
Yeah.
So, what is the next step? K1. So, the factor 5 is 0.95. So, K1, what is K1? K1 is the duration factor. Right?
Yep.
So what is the duration factor? Where to find the duration factor? Table? Which table? 2 point what? 2.5?
2.3
2.3. So
and G1.
if we go to table 2.3, what is the factor? He mentioned that the bit loop we have G and Q. So table 2.3. K1 for G and K1 for Q, both of them will be how much? 0.57. Why 0.57? Because both of them are 50 plus years. Okay? What is the next step? Or what is the next factor?
K4.
Where to find K4?
G1.
G4?
G1. Table G1.
So K4.
Wait. No way, I lied. Double 0.9.
Yeah, K4.
0.9.
K4 is for seasoning.
It's the weather.
No, K6 is the reason.
Oh, is it?
What is the timber season? Season MGB. So where to find K4?
2.4 to 0.2. Claw 0.2. The space between the members of 400 meters of the house was located in the northernmost part of Darwin, which is very humid. In fact, it loaded with this technology.
So how much is K4, guys? So if we go to the standard again,
1.
it is season timber.
Yes, 1.
So for season timber, we can take it as 1 when, but the value of K should be the greater of this 2.
0.7.
So we don't know EMC yet, so we can take it as what?
0.7.
0.7, because this is arid areas or high temperature areas, so we can take it as 0.7. So K4 is 0.7. K6, K6, directly how much K6? 0.9. Why 0.9? Because it is in the hatchet area in Darwin. So K6 is the temperature factor. So if we go to find K6, so K6 can be taken as 1 except when season timber is used in structure in the coastal region of Queensland North and all other regions north. So according to the map here, so any area in this hatchet or gray area should be taken as 1 for season timber 0.9. the Darwin or the North Darwin in this area, so K6 is 0.5. Okay, if we go back to our calculation, so we need to determine K1 for the loop combination. What is the loop combination we have? So K1 depends on the loop combination. According to table G2. So what is the loop combination? We have 1.35G, 1.2G plus 1.5 Q, and 1.2G plus 1.5 epsilon L Q. So where I get this loop combination from? Table G2. Let's have a look at table G2.
G2 or G1?
G1? G1.
G1.
So this is table G1. So for table G1, what are the loop combination we have? We have only dead load and live load in this case. How much is the dead load? 20. So how much is this load? 20. So 1.35 times 20 give us a value of 27 kilonewton. How much K1 for this one? As you can see,
0.57.
0.57. For the second one, 1.2G plus 1.5 Q. What is the load? Concentrated load, right? Concentrated load. And it is roof, from the roof. So G is 20 and Q is
39.
10. So how much is this value?
39.
39 kilonewton. How much K1 for this one? 0.97. Why 0.97? Because it is roof life load and it is concentrated load.
Yeah.
The third one, we have epsilon L. How much epsilon L for this case? So G is 20, Q is 10, epsilon L is 0.4. Where to get epsilon L? 1170 point what? If you open the file of the workshop, they give you the values of epsilon L.
Yeah.
So in the file itself, but if you want to get it, you need to go where? So he give us here the loop combination and also epsilon L. What is epsilon L here? We are concentrated or distributed live load? Concentrated. So the second word. The load comes from where? Roof. Right? Load of domestic household.
Sorry, 0.4.
Right?
Oh, sorry. Are you using 0.6? Or is 0?
Just need to read again. Does he mention it is roof or
Concentrated weight.
yeah? The R factor from the roof. It is clearly mentioned the R factor actually looks from roof. So we have roof used as floor. I think we can use roof used as floor. It is not clear, but we can use it as 0 or what. It's up to you. Depends on the specific case. In this case, if we consider it as roof as used as floor, so how much it is?
0.6.
0.6. If it is all other roofs,
0.
If it is a normal roof with nothing above, so how much it is?
Zero.
0. Know what is mean by roof? So they use the roof to maybe put something above the roof, like use it for any activity. So if it is roof used as floor, so this is 0.6. I just have a solution really prepared by someone, but it's not correct. They take it as 0.4. It can't be 0.4 because if it comes from roof, so it can't be 0.4. So I will ask Koi to update the solution because before sending it to you. Okay. So it is not 0.4. So how much is the factor K1? How much is this value first? Can you calculate it for me?
So
So 1.2 times 20 plus 1.5,
33.
33.
W y linear.
How much K1 for this one?
Sama to message configuration okay.
0.57. Why is it 0.57, Michael? Because it is long term life load. The life load is acting for long term. Okay?
Fuck did he get
So here, because it is a long term loop, how I know this long term? Because this is what he mentioned in the example. So if we look, how can we calculate the critical load combination? If you remember from last year, what do we need to do? After we calculate the factor and the load, we need to divide, make a table. So I will make it a table.
somewhat.
So how much is the first load combination?
Huh?
27.
More than a ko.
And we should divide by what? 0.57. The second one, 59, and we should divide by 97. And the third one is what? 73, and we should divide by 0.57. So which one is the most critical one?
Third one.
Third or second?
Third.
Third. So if we calculate to be sure, how much is the first one, second one, third one?
Is
What I did here is the loop combination divided by K1.
47, 40, and 57.
47, 40. Second one,
58. Oh, sorry, no, that's the last one.
Yeah.
That's 40.
So from the first one,
So that's 47.37.
yep.
40.21.
Yep.
And 57.89.
Okay, so this is the loop combination after we apply the factor K1. So what we should do is we need to calculate the loop combination and then calculate K1 or determine K1, then compare. Which one is the most critical one, Matthew?
Bottom one.
The bottom one or the third one. So which one is the critical loop combination? For our calculation, 33 kilonewton. So when you design for the 33. Okay? Which come from where? 1.2 G plus 1.5 epsilon L Q. You understand how we do that? All good in the first example?
Yes.
Any question? No? So the second question, we still have ability to do it. What is the second problem? The second problem is a rafter 12 meter in office building from Gruland in Addis. The unfactored distributed load on the rafter are this load, life load, short-term life load, and wind load. Then we need to determine the same factor. Anyone can help to do this one?
0.85 category 2.
Okay, so for Q2, 5 is 0.85 from table what? 2.5. Why, Jimmy?
Because it's a primary structural member in the structure other than the house.
Yeah.
And it's
So rafter?
laminated.
Yeah, we have rafter in building other than house. And what is the type of the timber? Glue lamp. Okay. So this is not house and this is glue lamp and primary member, not secondary. So maybe I will stay here. Give it to one. Okay, so what is our case? Primary structure member in structure other than houses. So I have category 2, not category 1. Okay, what is the grade of the timber? Glue laminated, so how much is the factor? 0.85. Okay. What is K1? I think K1 we don't need to calculate for each load, we calculate only for the load combination. So let's go to K4. For K4, what is K4 again? K4 is the seasoning coefficient, or the seasoning parameter.
Yeah.
So this timber is seasoned or unseasoned?
Season because it's
Yeah.
generally
If it is
Yeah.
manufactured, so it is seasoned. Okay? Because it is manufactured, so it is generally seasoned. Okay? So how much K4? 0.7.
When do we take it as one?
Yeah, but we can't take it as one because it is not humid area. So if we look to K1, K4, sorry, for seasoned timber, generally K4 is 1, where
When the season timber is subject to a condition which is average moisture content for 12-month period, let's say.
so we can assume that this one is not in humid area because it is not in humid area.
Yeah.
We can take it as 1.
Okay, makes sense.
The same thing last week.
Roger that, mate.
For K6, how much K6? K6 is 1. Because
One,
one.
it does not say
Darwin,
right?
so not in Darwin, so K6 is 1.
Yeah.
He says it has text on it.
Okay. So determine the critical load combination acting on the rafter for the ultimate limit stage design. What are the load combinations for this case? If we go to table, which table? Table G1. For table G1, what are the load combinations in this case for the ultimate limit? If you look table G1 for the strength limit state. Okay? So strength limit state means alpha. For strength limit state, what are the combination we have in this case?
Deadline, large load, long term, short term.
yeah.
What is the load we have?
Dead load
The load we have are G, dead load, Q long term, and
and short term.
Q short term. What else? Wind.
Upwind, yeah, wind.
So how many load combination?
4.
1.35 G, 1.2 G plus 1.5 Q,
Yep.
1.2 G plus psi C, psi L, sorry, psi L Q. What else?
Are we doing the 1.2G plus wind plus site combination Q?
Yeah.
Yeah.
We have the. We don't have the. We have uplift wind, right?
Yeah.
So we have the fifth one, not the fourth one. So 0.9 G plus W. Why? Because he mentioned that the wind is uplift. So for the first one, how much is G? given to us 2, but G is 2.
2 kilonewtons meters.
So this is 2.7 kilonewton per meter, right? What is the factor of K1? 0.53. For the second one, G is 2. How much is Q? 1.4, right? Because we have 0.6 and 0.8. Is that correct or not?
Isn't it? You add them together. The Q's.
Yeah. Because this is the general, this is the total life load. So Q here is 0.6 plus 0.8 or 1.4. So how much this two combination?
That is
1.2 times 2 plus 1.5 times 1.4. So how much?
what it ends up being. It goes. I got 4.639.
4.63. So this is what is the factor in this case?
Oh, sorry, it was 4.5.
4.
That was after other stuff.
Yeah. So 4.5. What is K1 for this case? He mentioned the load comes from
Distributed.
yeah. I think we can take it for floor distributed. If it is floor distributed, how much is the factor?
0.8.
20. What is the next one? You take it 0.9. Why you take it 0.97?
What's this?
You take it as 0.97. It cannot be
Concentrate.
0.97. Okay? And
Concentrate.
the solution you take it as 0.97, which is wrong. Because 0.97 is for concentrated
Concentrated, yeah.
for roof. Okay? Just ignore this one. That is 0.8. What is the next factor? Psi L. Do you know how much Psi L in this case? Psi L, we are considering distributed load, right? Which case office?
Sorry. In
So 0.4. This one is okay.
sorry, in the problem it says unfactored distributed load on the rafter. So should that be roof distributed?
Yeah, it can be roof or floor because the office also will have this mountain. It can be the roof or the floor, but it is for the distributed one. So it can be 0.8 or 0.94. If we consider it as a roof beam, so you can take it as 0.94. If it is floor beam, it is 0.8. So I assume here it is what? Floor beam. What is the next one? Because the first one he clearly mentioned it is for a roof, but this one he didn't. So this one is 2. How much is psi L in this case? 0.4. How much Q? Q here is the long term load. Can you see? Psi L means long term.
Yeah, long term, yeah.
So we only consider what?
Long term.
0.6 or 0.8?
0.6.
0.6. So this one is 0.6. Can you find this value?
Read it to me.
It is
0.12. Oh shit.
2.94.
2.94 kilonewton per meter. What is the factor? K1?
0.57.
0.56.
I got 2.76. 2.76.
Oh, sorry. No.
What is the last one? G. How much is G? 2. How much is the load? Wind load?
I thought it was still on
3.
0.4. Yeah, sorry.
Don't forget that 3 is what? 3 is what? Uplift means negative. Okay?
Okay.
So how much is this one? 1.8 minus 3. So it is negative 1.2. What is the factor? K1? K1 is 1 in this case. So as you can see, we have actually 2 cases of our load combination. So anyway, we will take the first one alone because we have now 2 directions of the load. So we need to compare these three to select the critical. How can we select the critical of these three? We need to divide 2.7 divided by 0.57. Here 4.5 divided by 0.8. Here 2.76 divided by 0.56. Can you find these three values? What I mean is, anyway, we will take this one as critical because it is in the opposite direction. So we have negative 1.2, we are getting there. Which one of this is the critical one or the most critical one? Can you calculate these values for me?
The second one.
Second one?
Yeah.
So how much is the first one?
4.74.
Second?
Maybe.
5.6.
Third?
4.8.
So which one is the most critical one? Number 2. So our critical loop combination for this case are 2. Downwards we have how much? 4.5. Upward we have how much? 1.2. Does it make sense? So if we have two directions of the loop, we cannot compare them, right? What is the last step? Stability loop combination. For the stability loop combination, we don't have factor K1. Just make sure. Do you have a quick problem with this one first before we proceed? All of this is what? Permanent or sorry, strength loop combination. For stability loop combination,
Question sheet doesn't even say what it
4.3. Yeah, search up 4.3. Keep going.
Ahmed, did you go through the article previously? I think you have time to do it now.
we have recording, I will share it.
How about still in concrete?
Ahmed got long time to do.
Okay, for the loop combination for the stability, you don't have K1 first. So K1 is about only for what? For the strength loop combination. Okay? So for the stability loop combination, what you should do? The normal loop combination, you don't need to divide by K1. So what is the loop combination we need for the stability?
Deadline.
Actually two. This one, G plus epsilon LQ. How much is G and how much epsilon LQ?
G is 2.
Yeah. So for stability,
Done quite a bit, so
no, K1. Okay? So we need just to go table B1, as you can see here,
I'm telling you, he's just on a mission.
and we'll calculate normally and compare which one is greater. Okay? So how much is the first one? G plus epsilon L Q. How much is G? 2
Two.
Newton per meter. How much epsilon L? 0.4. How much is Q? You long term.
Long term 0.6.
0.6. So how much total? 2.24?
2.24, yeah.
Okay. So this one?
Genius.
So what is the next one? WS for self-determined effect, WS or Psi SQ. WS, we don't have WS downward, so we don't care about uplift wave. Okay, so which one is the second one? Psi SQ. So actually we have only two combinations. How much is Psi S? Have you calculated?
Which one?
Psi S?
Short term 0.8 times by
Where is
3.
it?
0.8 times by 3. 2.4.
This is same table, okay? Table 4.1. We are in office, so it is point what? 0.7. So for office, it's 0.7. For office. So how much is the Q? Short term Q? 0.8. So this one is how much?
0.56.
Okay. So which one is the most critical one?
The first one.
The first one. So here we don't need to divide by Q1 because it is not mentioned in the standard. Okay. So what is the critical combination for self-stability? G plus Psi L Q, which is 2.4. But the main thing, do you understand this one? Why we have two here again? Because we have one upward, one downward. Okay. If this one was positive, this is the last one. So if it is positive 1.2, so we put it in the comparison with the 3, and which one would be more critical? The same one. But I mean, we just separate it alone because it is negative. Okay. Okay. Thank you, guys. Do you have any question?
Yes.
Too long session. You still need help with?
Just one